Hello and welcome back to Math 121. This is a video over section 3, and what we're going to be doing is dividing polynomials. We're going to be using the remainder and factor theorems. Okay, so I'm going to talk to you about that. Now, when we do division, dividing polynomials is really just another way to factor. Okay. And when I say that, it's a way to factor polynomials when polynomials of very large degree. Okay, so this is for polynomials of larger degree. All right, so that's when you have like really big, large degree. All right, and so that's when we've got like really, really big polynomials, like when you see, like if you've got something like an x cubed type of polynomial, those are the types of polynomials that we're going to be factoring. And we do that by using division, okay? So let me give you an example, okay, because we got a couple different things we've got to talk about. We need to talk about long division, okay? We need to talk about synthetic division. And we need to talk about the remainder theorem. And you're going to want to write small because we got a lot to talk about on this one. Okay. And so let's talk about that. And what I want to do with long division is I want to simply divide a polynomial by another binomial, okay? And that's kind of the initial thing that I want to talk about. So let's do this. Let's say that we're taking x cubed minus 2x squared minus 4, and then we're going to divide that by x minus 3, okay? So this is the this is a rational expression where you've got one polynomial being divided by another polynomial. This is a trinomial of degree 3, and this is a binomial, okay? So when I do this, I'm going to write it out in long division terms, okay? And I'm going to put my x cubed minus 2x squared. Now notice that I don't have a 0x here, okay? I need to put in, or any term with an x. Okay, a single just x to the first power. Since I don't have that here, I do need to put a placeholder for that. So that is important that we are able to do that. So plus 0x and then minus 4. Okay, and so now what I do is I do long division. All right, we think, you can think about, long division of a number. It's the same kind of thing. And what I ask is this. I say x times what is going to give me x cubed. Okay, and so I ask that question, always on this leading number here and my first number here. And what I get is this. I get a 2x, or I'm sorry, not a 2x, just an x squared, okay? And so if I take x squared and multiply it by x, I'm going to get x cubed, all right? And then if I take x squared and multiply it by negative 3, that's going to give me negative 3x squared. Now what I have to do is subtract the quantity. This is the big part of this, where a lot of people screw up, okay? And so here's what I'm going to get as a result. I'm going to get x cubed minus x cubed, all right? And that's going to cancel out to 0, okay? And you always want that to happen with your leading number, all right? And then if I have negative 2x squared minus negative 3x squared, that's really negative 2x squared plus 3x squared, which is just going to give me a positive x squared, okay? I'm going to drop down my 0x, so plus 0x, and then I'm going to repeat that same process. And now I ask the question, x times what gives me x squared? And that's simply just going to give me an x. Okay, so I'm going to put a plus x here. And so then I get x times x minus 3, which is just going to give me x squared minus 3x. And then I'm going to subtract the quantity. And so then I'm going to get x squared minus x squared. That's going to cancel out. I got 0x minus negative 3x, it's going to give me a positive 3x. Okay, and then I subtract my 4. All right, so now I ask the question, x times what gives me 3x? Okay, and that's going to give me a positive 3. So I'm going to put a plus 3 here. All right, and so 3 times x minus 3 is going to be 3x minus 9. Okay, if I subtract that quantity, then I get down to this point here, 3x minus 3x is going to cancel out. And then I've got negative 4 minus a negative 9, which is really negative 4 plus 9. So that's going to give me a positive 5. Now, this is my remainder. Okay, and we're going to use that here in a second. But our remainder here is 5, okay? What we want, when we normally do long division, we want a remainder of 0, okay? So we're going to talk about that here in a second. What that means when you have a remainder of 0. Okay, that's what we're kind of looking for, all right? We are looking for this. All right, but we have a remainder of 5, and that's okay, all right? What this tells me is that if we have a remainder, this tells me that this does not divide evenly, okay? That this does not give me a nice even number. If we get a remainder of 0, then this divides evenly, and when it divides evenly, we're actually factoring this, okay? So now what I want to do is the same problem, but using synthetic division, okay? And so the same thing's going to apply here, okay? I'm going to do the exact same thing. I'm going to show you what we get as a result, and we get the same thing. It's kind of an easier way of doing this, but it kind of depends on the numbers and the polynomials that you've got. So I want to do the same problem, but the first thing I'm going to do, since my divisor is x minus 3, what I want to do is find the 0, okay? And what that means is I'm going to take x minus 3, I'm going to set it equal to 0, and I'm going to add 3 to both sides and use x is equal to 3, okay? And that's going to be my way of doing this problem, okay? I'm going to use 3 as my divisor, okay? And then I'm going to draw this little line here, and I'm going to use the coefficients of my original polynomial. Okay, so I've got a 1, a negative 2, a 0, and a negative 4. So I'm going to come in here. I've got a 1, a negative 2, a 0, and a negative 4. Okay, and when I use those, watch what happens. Okay, I'm going to drop down the 1. Okay, and I'm going to take 3 times 1, which gives me positive 3. I'm going to add these together, which is going to give me a positive 1. And then I get 3 times 1, which is 3. 0 plus 3 is 3. I've got 3 times 3, which is 9. And I've negative 4 plus 9 gives me 5. Okay, these numbers should look fairly familiar to you. This is my remainder. Okay, and this is my quotient. Now, these are the coefficients of my quotient, okay? What I'm left with is this as my answer. I'm left with an x squared plus an x plus 3, okay? And that's the same thing that I got up here, all right? And so what I'm doing the same thing. This is much faster and much easier, okay? We should still know how to do long division because it will come into play, because you may have to divide something that isn't a binomial here. You may have to divide something that's like a, quadratic or something like that. So that's where you would want to use long division. But if you're dividing by binomials, we're going to use synthetic division. It's a lot easier. Okay, now, the remainder theorem says this. Let's say that you've got a function, f of x, okay? And so f of x, if f of x, so let's write this, if is divided by a binomial, say x minus k, okay, then the remainder is f of k. All right, so this is kind of confusing, all right? But here's what this means, all right? Remember what we did here, all right? What we did is we took some function, x cubed minus 2x squared minus 4, and we divided it by x minus k, or x minus 3, okay? And we got this quotient, all right, here, but we also got this remainder of 5. Then let me do this. What I want to do, we did x minus k, all right? What I want to do is plug in this k value, which in this case is 3, all right? So I'm going to plug in 3 into this function. So I'm going to label my function here as f of x is equal to x cubed minus 2x squared minus 4. I'm going to find f of 3, and I'm going to bet you guys $1 million that I get 5 as a result. When I plug in 3 in for x, I guarantee that I'll get 5. So check this out. If I do 3 cubed minus 2 times 3 squared minus 4. Okay, 3 cubed gives me 27 minus 2 times 9 minus 4. So I've got 27 minus 18 minus 4, which gives me 27 minus 22, which gives me a value of 5. Okay? So the cool thing is, you know, that's pretty cool what that does. Okay, A. But all these things work together. Okay? If I do synthetic division, I can evaluate polynomials. Okay? Knowing the remainder theorem. Okay? Now remember what we're looking for. We're looking for when we get a remainder of 0, okay? And this is kind of the most important part. So I want to talk about zeros. Okay, zeros, this is where the graph crosses the x-axis, okay? We're looking for that. When we and what that does, you know, this will help us graph polynomials. This will help us solve polynomials. Okay, and so we use this concept of the remainder theorem, you know, to factor, all right? And so, you know, what we're essentially doing is we're looking to see when does the graph cross the x-axis, all right? So there's a bunch of things that we can do for this. So go ahead. I want you guys to, you know, get started on and finish these problems. Okay, good luck.